Hello everyone, let's start this session to know about the number representation for a computer system. We have said the computer can understand only 0 and 1 because it is a digital machine, right? But the input what we are giving to the computer, it will be in the form of character code or it will be in the form of decimal number. But ultimately the input what you are giving, it will be converted back to the form of zeros and ones. So here the string of bits what we are taking, it will be called as binary digit. So string of bit is nothing but string of zeros and ones. Similarly, a string of character, it will be called as a character code. So the ultimately the input what we are giving, it will be in the form of text or it will be in the form of decimal number, where automatically it will be converted into the form of zeros and ones. Now we will look into the number representation, which is where we are using both positive and negative representation for the computer system. So here we have tried to take a vector. So this vector to represent a unsigned integer value. So unsigned what we are using here, it is to say that the number what we are using, it is a positive number. The vector is written something like b0 into 2 power 0 plus b1 into 2 power 1 for n numbers till bn minus 1 into 2 power n minus 1. So now we are saying that there are three kind of methodology we are using to represent both positive and negative numbers, and these methods are nothing but sign and magnitude, 1's complement and 2's complement. Sign and magnitude, 1's complement and 2's complement. In all the three systems, whenever we are representing positive numbers, they are same. But the difference comes when we are trying to represent the negative number. So here in all the three systems, when we are representing the numbers in the positive form, the MSB will be 0. Whereas while representing the negative numbers, there comes the change where MSB will be 1. For positive number, MSB will be 0, and for negative number, MSB will be 1. MSB will be 1. So whenever we are dealing with binary numbers based on the MSB, we can say that whether the number is positive or negative. If MSB is 0, you can say that the number is positive, and if MSB is 1, you can say that the number is negative. Now we'll look into the sign and magnitude. The sign and magnitude is the simplest way of representation, where by just changing the MSB, we can make the number to negative from positive. For example, take plus 5. So since you have taken plus 5, then MSB will be 0, right? And 5 is represented as 1, 0, 1. If you want to represent minus 5 in sign and magnitude, you just change your MSB from 0 to 1, and 101 will be same. Since MSB is 1, you can say that it is minus 5. So sign and magnitude says that just changing MSB from 0 to 1 will get us negative number. Whereas in 1's complement, already you have studied in the basic electronics how a 1's complement can be represented. Here every number will be inverted. Like if it is 0, it will become 1, and if it is 1, it will be 0. For example, take 101. The 1's complement of this number can be represented as 010. Good. That is, every number is inverted. This is called as 1's complement. And we have one more method to represent a number in 1's complement, where the number will be subtracted by 2 power n minus 1. So here we say that n is the number of bits we are trying to use. For example, if n is equal to 4, then the total count will be like 2 power 4 minus 1, which is equal to 16 minus 1, nothing but 15, right? So now we said that to find out the 1's complement number, you just need to subtract the given number from 2 power n minus 1, nothing but you have to subtract the given number from 2 power n minus 1. For example, you just try to know, you have taken 4, right? This is, I'll say, plus 4. Now to get the minus 4, you have two methods. One, you can complement each of the bit. This is 0, 1, 0, 0. This is your plus 4. You can complement each of the bit to get it as 1's complement, or else you can subtract the given number from 2 power n minus 1. So 2 power n minus 1 we have said it as 15 minus 4, nothing but 11, right? So in 1's complement, the minus 4 will be represented as, it has to get the number as 1 1. Just look at this. So plus 4 is 0 1 0 0. We take out complementing each of the bit. So each of the bit will get you 0 will become 1, 1 will become 0, 1 1. So how much is this? 11. This is the representation for 11, nothing but it is minus 4. So in 1's complement, you can complement each of the bit, or you can subtract the given number from 2 power n minus 1. Whereas 2's complement number says that you have to take 1's complement of the given number, then you have to add the 1. Then you have to add 1 to the complemented number. It will get you 2's complement. Or else you can directly subtract the given number from 2 power n. So we have to find out 2's complement number means you have to take first 1's complement plus then you have to add 1 where you will get it as 2's complement. For example, we will take out same plus 4 which is equal to 0 1 0 0. To find out 2's complement, first you have to take 1's complement of this number, then you have to add 1. So first we will take out 1's complement. So 1's complement is 1 0 1 1. Then what you have to do? You have to add plus 1. 1 plus 1 0 with the carry, 1 plus 1 0 with the carry, 1 1. So this is minus 4. This is minus 4. Or else what you can do is, the given number is plus 4. You just subtract this number from 2 power n, nothing but 2 power n minus 4. So 2 power n, again it is 4-bit number we have taken. So it will be 2 power 4 is equal to 16. 16 minus 4 is equal to 12. I will just confirm it once again. So plus 4 you have taken it as 0 1 0 0. You have taken 1's complement. Then you added plus 1. So this is the representation of 12. That what we have got in the previous method, where we have said that it has to be 2 power n minus 4, nothing but 16 minus 4 which is equal to 12, right? So this is 2's complemented number. If it is 1's complement number, you have to complement each of the bit, or else you can subtract the given number from 2 power n minus 1. If it is 2's complement number, you have to subtract the given, you have to subtract the given number from 2 power n, right? So you can find out the 1's complement and 2's complement number like this. So n is, we have said that it will be the number of bits you are taking to represent. For example, if you are taking 2 bits to represent, then it will be 2 power 2, which will be like 4. So the 4 combinations you get it as 0 0 0 1 1 0 1 1. If you are taking it as 3-bit, then it will be 2 power 3, which is equal to totally 8 combinations you will get, where it will start at 0 0 0 and ends at 1 1 1. Similarly, if you are taking it as 4-bit number, then it will be 2 power 4, which is equal to 16, where the number will be starting at 0 0 0 and ends at 1 1 1 1. This is how you have to take out your n. Based on the n, you can find out your combination. So based on these numbers, we have made out a table over here to represent all the numbering system. So now we said, just now I said, if it is a 4-bit number, totally we will get 16 combinations. You can see here. I have started at 0 0 0 and 1 2 3 4 5 6 7, the upper one, and lower one 8 9 10 11 12 13 14 15 16. So just for easy to understand, we have separated as where we have given the numbers to the upper side, where all we have taken, where you have the numbers MSB as 0. You can see here, right? We have separated it, saying that the MSB is 0, and the lower one is the numbers where you have MSB as 1. Now the same numbers we are trying to represent in the different methods. One is sign and magnitude, next is 1's complement, and the next one is 2's complement. Already we said that when we are representing the positive numbers in all the three methods, there is no change, right? You can see this is 1 1 1. Since it is 0, we will say positive. So 1 1 1 is nothing but 7. So 7 we are trying to represent in all the three methods: 1's complement, 2's complement, and sign and magnitude. Similarly, you have till 0, we have the same representation, where the difference comes when we are trying to represent the negative number. We said if you are trying to change, if you are just making the change in MSB, that is MSB from 0 to 1, if you are changing, then it will become negative number in case of sign and magnitude. Here you can see, in case of sign and magnitude, we are changing MSB from 0 to 1 so that we can get the negative number. So it was positive 0 here. Here it was positive 0. Now it is negative 0. Similarly, you can represent the number for 1, 2, 3, 4, 5 and 6, 7. So here. All the numbers has been represented for for sign and magnitude. Similarly, we will check out for 1's complement. In 1's complement, we said that for a given number, you can find out 1's complement by just complementing each of the bit, right? So we have taken 0 0 0 over here, this 0 0 0 over here. Since MSB is 1, of course it will be given as negative number. For 1's complement, what we have to do, we have to take the complement of 0 0 0. So complement of 0 0 0 means 1 1 1. So 1 1 1 is given as 7, right? So that is why it is represented as minus 7, right? So like this you have to find out for all the numbers in 1's complement. Whereas in 2's complement, what you have to do, you have to take the 1's complement of the number, then you have to add 1. So for that you will get it as the 2's complement number. For the given number 0 0 0, if it is sign and magnitude, in negative it will be represented as minus 0. Whereas if it is 1's complement, it will be represented as minus 7, and when it is 2's complement, it is represented as minus 8. How? Just take out the number 0 0 0, right? When you have taken 1's complement, it became 1 1 1. So based on the MSB, I have said it as it is a negative number. Add 1 to this. 1 plus 1 0 0 0 with the carry 1, where this is the representation of 8. That is why it is represented as minus 8 over here. This is how you have to find out 1's complement, 2's complement, and sign and magnitude of the number both in positive and negative.